Hello, hello, lovely people. I see your guest is dancing on the countdown sound. Yeah, it does that all the time. It's just a peppy sound. It's a way to start like the show with some energy. Folks, always happy to be here. I know you missed us. We missed the last live stream 2 weeks ago because life happened. But we're back, and should I say, pretty strong for that show. We have a guest. Really happy to have you here. But because we're not polite people, let's start. John, how are you?
I'm doing really well, Fred. Thanks for asking me how I'm doing. I'm doing really well. How are you? How are you specifically doing today, Fred?
I not that bad, not that bad, not that back, not that bad. My back is acting up a little bit, but outside of that, life is good. Live stream days are always a good days for me. I just love being here, learning about new stuff, and having amazing guests and talking about amazing guests. We have Matt with us. Who are you, Matt?
Well, first of all, I'm a philosopher by trade or by training. So you should never ask a philosopher who they are unless you want to spend the whole live stream on what does it mean to be a person. But I've been a software developer for longer than I've been a philosopher. I started doing software development in high school. And these days I'm the CEO of Fermyon and have kind of moved my way through all kinds of phases along that journey. Fermyon, we're a startup that's been around for about 3 years. In fact, 3 years as of next week. And so I'm just having a great time right now as we kind of do that startup thing and build our first products and experiment with some really new and cool technology like WebAssembly.
Yeah, we're looking forward to diving into WebAssembly with you. I have to confess to our audience that I'm not a WebAssembly guy at all yet. I've studied it just in the sense of reading blogs on the new stack and whatever, and trying to keep my finger on the pulse of the industry. But I've never really had a good deep dive on WebAssembly. I think this is going to be a really good opportunity, certainly for me, but hopefully for our audience as well. That's kind of into platform building, has probably heard a lot about WebAssembly. Could probably use a little bit of education on the topic. And I think we got just the right guy for that.
Yeah, it'll be fun.
Yeah, that's gonna
accurate. I don't know. Fun, I guarantee.
I like that. I like that. Yeah. No, that should be a good show. I mean, I have some knowledge about WebAssembly, but like it's not a focus of mine since the last couple of years. I mean, when I was working at Mozilla, we were starting to talk about like a possibility of like something that could look like that, but I left before it became a reality, and it was part of like me being like a developer advocate in the web industry, so that was part of it. But I will probably have some question also about it, like where is it right now in terms of like the technology. But I think that even before jumping to that topic, I would like to learn a little more about Fermyon. Like what's the company, what are you doing, what's the offering, what are you working on?
Yeah, so we got started because we had kind of landed on a particular problem that we felt like really needed to be solved. So a bunch of us were at Microsoft, and you'll see that story sort of weave in and out here as we talk about Helm and other stuff. But a bunch of us were there working in like pure open source development. We were in the Azure team. We were working on a whole variety of different projects. And kind of our way of doing things was to work on a project, bring it to fruition, release it as open source, get it into CNCF. And then as we were continuing to mature that project, try it again with a different idea and see if we could do the same thing again, and just kind of continue to bring interesting projects forward. And we ended up, looking to try and solve some very specific problems with bringing serverless style architecture, which was popular in like Lambda and Azure functions, into sort of like into this kind of V2 era, right? Where it could do more things, it could do it faster. You weren't necessarily getting locked into a cloud. And that was kind of one of the ideas we were playing with. And we were trying to figure out how to do that. And we were looking for a core technology that would drive it. We started talking about it as like, we think there's a third wave of cloud computing, a third kind of cloud compute that sits alongside virtual machines and containers. And this one would have the characteristics that you need to be able to run serverless functions as workloads. And so we dabbled in a bunch of technologies, ended up with WebAssembly, and we'll talk about that quite a bit in the future. But what we ended up doing, we pitched it at Microsoft and said, we think we should start this brand new, big giant project. And it didn't manage to convince the leadership that was the best thing to do. However, my boss came out of the meeting and was like, I think this is a really good. Brendan Burns was my boss. So Brendan Burns, a guy who created Kubernetes, excellent boss. And one of those people who's always got the visionary glasses on, right? And it's like, where are we going? Where are we going to be in 5 years? Where are we going to be in 10 years? And he kind of came out of this meeting and he's like, this is a good idea. This is the kind of thing people build startups on. I don't think he meant to tell me that it would be a good idea to do a startup, but I came out of the meeting going, maybe a startup would be kind of a fun thing to do.
Yeah.
So 10 of us from the team left Microsoft on the same day and started Fermyon with the idea that we were going to build this kind of third wave of cloud compute that would power the next generation of serverless functions, and that WebAssembly was going to be the core technology that we did. And so along the way, now we're, coming up on year number 3 in only a week and a half. It's very exciting. But what we've been working on is we started with sort of trying to identify and build the right developer experience. So for the first year and change of Fermyon's history, we had one top level user story. And it was like, as a developer, I can go from a blinking cursor to a deployed serverless application in 2 minutes or less. We were just like, you got to win the developer over. You got to build them tools that are really easy. If they can get the hello world done in 2 minutes and then start going from there into building the application they actually wanted, that's a huge win. And I had timed it against the how long it takes to build your first Lambda function thing, which was 42 minutes, and thought, okay, this is ambitious, but if we can do it, it's a big win, right? So we built Spin, which is the developer tool for this. And the easy way to kind of find out about Spin, if you're a developer, go to developer.fermyon.com and then just click on the Spin button and you can get started there. If you want the high level view, you just go to fermyon.com and click on the Spin thing there. But that'll get you right into the development part of it. So we built Spin first. And then after that, question number 2 is, once you got it, where do you run it? Right.
Right.
And so we built Fermyon Cloud, which was kind of a hosted version, our own hosted version. So we could really start to dive into how to build, a real production grade service out of this. Just kind of made it free for developers to try out. And what we heard back from people was, yeah, that's cool, but can you run it in Kubernetes?
Okay.
And, so of the 10 of us who initially started, all 10 of us worked in Kubernetes, and many of us contributed very, very early in Kubernetes. And then of the, next 10 engineers we hired, most of them were also in the Kubernetes space. Either Kubernetes or WebAssembly was their kind of core competence. So it was like, well, yes, we can build a Kubernetes runtime for this. We can absolutely build a Kubernetes runtime for this. So we actually partnered up with SUSE, with Microsoft, with a couple of other companies. And we built SpinKube, which is spinkube.dev, and that's Kcube. Yeah, there you go. And the idea there was to build a runtime that just, you could install it into any Kubernetes cluster and within a couple of minutes be able to start deploying WebAssembly applications, serverless functions powered by WebAssembly that were running side by side with your containers, sometimes even in the same pod. And so that was, the thing about doing startups, right? It's hard. You work long hours. Yeah, blah, 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 whatever. You get to do what you want to do. And it has been so much fun to build these kinds of things out. So these days, we're still working very actively on Spin. SpinKube, we've contributed to CNCF, and we continue to work very actively on that. And I think that's the groove, right? We've kind of found how we want to build things and how we want to do things. And we're starting to, reach out to the community. So Spin itself has about, probably 230, 240,000 downloads of the Spin binary. SpinKube, we just launched at KubeCon Paris. And it's already crossed, I think, the 10,000 downloads mark or something like that. So we're definitely seeing momentum really pick up. We're really excited because at KubeCon coming up in only a few weeks also, so many things coming up in November. We'll have some new versions and some brand new features that we're going to launch for both Spin and SpinKube. So it's going to be a fun demo time. By the way, KubeCon has a pre-day event called WasmCon this year. It's a 2-day event, Monday, Tuesday. It's actually used to be Wasm Day, and it's expanded to a 2-day thing. So if anything I say in here sounds fun and you're already going to be at KubeCon for some of those pre-days, stop by WasmCon on that Monday or Tuesday, and you can come hang out with a bunch of WebAssembly folks and kind of see what state of the art is and what all these different organizations are doing with the technology. So I think there you go. That's kind of the background of what we do. I think I just threw a whole bunch of terms out there that we're going to have to define a little bit later, but that's how we do things.
Yeah, you do have me ready to ask my very first questions about WebAssembly, which is like what I want to understand is with WebAssembly. Like I understand conceptually, at least, that like it allows you to run non-JavaScript apps in the browser, and I barely understand that. And then what I hear you describing is that the industry wants to run WebAssembly someplace, preferably in Kubernetes. And while I understand the attraction to running software in Kubernetes, I don't understand fully what it is that's being run in Kubernetes if WebAssembly is intended to be run in the browser. Can you help me sort of navigate that line of thinking?
Yep. Yeah. And we can start this story with Fred, because you were working at Mozilla probably 2014, 15, sometime in there.
Just before. Yeah.
Yeah. And Mozilla is where WebAssembly started. So there were a group of researchers there that were working on a couple of different projects to try and build something the right way that had been built the wrong way multiple times. So let's talk about Java. When I was first starting, my developer career, Java was a brand new language, like 1.0, 1.1, something like that. And Java was originally built, and I don't think a lot of people know this, when it was called Oak, its original language incarnation, it was intended to be sort of like an IoT language before IoT was a term that we used. It was supposed to run in embedded devices, which is somewhat ironic in that, these days you're most likely to find it in very high-powered devices like really state-of-the-art phones all the way up to like gigantic data centers where people are running monolithic applications. But when I was first doing development, LiveScript had just become JavaScript, and Java applets were the new hotness. And the whole idea was, you'd have 3 languages to write a web page. The HTML would put up the static website or the static text stuff, and then Java would power any dynamic elements you had in there. And then JavaScript was just supposed to help you talk between the two ends of this, right? We all know how well that worked out because none of us use applets anymore, and I don't even think most browsers support them. It was a good idea, though.
I need to say, though. Sorry, I cut you. I was going to say it was a good idea.
So what would you say was the biggest weakness of Java in the browser?
I mean, that was the first thing I worked on, like Java applet. Like I built like a tool to design, like to kind of like a really bad paint application in the browser and welding simulator too that was a little more advanced, and the biggest problem to the adoption at that point, at least from the user standpoint, is that you had to install other stuff to run it in your browsers, and like it comes like security issue and stuff, so it was not part of the browser engine. So that was like one of the main problem I've seen on the user side. Though on the developer, that's a totally different discussion. But I interject before because I was going to say like that was not a bad technology at the time, and I think it came to do something that was not really possible to do in the browser at that time. But it didn't go well.
Yeah, no, and it was, and it was kind of like, I asked that question because like, I think it was a really good idea. Java is a fantastic language, and the Java runtime is a really elegant, specification and piece of engineering. But yeah, like it was hard to develop. It was slow. Of course, everything was slow back then. We were running on 486s, but there were all these. It was like you said, and the IE and Netscape implementations were uneven, and I don't even think Mosaic could run them. I mean, like the first gen browsers, everything was just sort of a little hodgepodge.
Yep.
And so Java kind of faded out as a browser language and kept on its enterprise trajectory, in which it's still the stalwart today. But several more times you saw that same pattern, right? Of people trying to say, let's see if we can add something beside JavaScript in the browser. And JavaScript, by the way, like, Fred, you probably had the same experience. It's like the first JavaScript I wrote popped up an alert dialog to tell you were leaving the site. You couldn't do that much. You couldn't interact with the DOM. People would make those little status bar crawlers. It was a toy language when it started. It was a good language with a toy API, really.
So JavaScript.
What?
It was fun though. I like doing those kind of things, and like I felt a little more empowered, like to build those things. But obviously, yeah, as you said, like that was really not powerful at all.
I think JavaScript is probably one of the biggest testaments to engineering and evolution over time of any technology I've seen. Right? It was a small language, special purpose. And it's just like over and over again, you've seen changes large and small that have reshaped its capabilities until, I mean, I remember so the DOM was originally static. You couldn't change text on a page once it rendered the first time. And when Netscape changed that and allowed you to use JavaScript to change the text on the page, it felt like I'd just gone from stone tools to having my very first shovel. I mean, it was like amazing.
Right.
And I had no clue at that point that we'd be building like massive server-side applications or things like Node.js or Deno or things like that. I mean, it's amazing. But, as JavaScript evolved, we tried several more times as an industry to do full software development in the browser, right? We had Silverlight, we had, Flash, which kept growing and growing and growing and then kind of went away. And, ActiveX, of course, we took all these shots at trying to figure out how to embed other languages besides JavaScript into a web browser environment. And so my understanding, and I was not at Mozilla like you were, Fred, but from talking to Luke Wagner, who is the guy who wrote the original blog post announcing WebAssembly and has been one of the first and most prolific contributors to that project. He sort of framed it this way, that there were some lessons they learned from watching how things had failed in previous iterations. One of which was, you have to do it open source and you have to do it as a standard. Otherwise, one browser implements it and the other ones resist, right?
Right.
Another one of those was, maybe it's too much to bite off to try and do the whole UI thing at the same time that you're trying to do a language runtime. Another one was, maybe you didn't have to be opinionated and write a brand new programming language or support only one or two programming languages. Maybe you could come up with some way to support a huge number of programming languages. And those were all some of the assumptions that led to WebAssembly. So, if you rewound to 2015 and 16 and said, what is WebAssembly? Then essentially the answer is, well, it's a binary format that runs in the browser and you can someday be able to compile all kinds of languages to this binary format. That was kind of the original vision.
It was really it was really coming also from the Mozilla vision about like the browser should be like the main tool you're using on your computer, and really the desire to say like, because it was like it was already popular to have like all those app stores and like having monopoly from like Apple that decide like how much you're gonna get, how much you're gonna charge, and all those things. And it was like also coming from the philosophy behind Mozilla was like trying to give the power back to the developers and the users. So it's like there's the technology side of it, but there's also like the part of like, let's try to do something good with it.
I didn't know that was part of that particular movement, but it totally makes sense. And in particular, I mean, one of the things WebAssembly was creating an opportunity for was to take crufty old C libraries that have been collecting to, okay, all right. So I actually thought this story was a myth, but it turns out it's real. So the story goes that when Microsoft was building O365, the browser-based version of Office, there was a particularly niggly bit of logic in Excel that worked fine in the desktop version where it's written in C, I think was probably the original language. The code had been gone for, or the developer who wrote it had been gone, had retired long since. And it was one of those pieces of code that apparently was like, rewriting this in JavaScript would be just, first you got to find somebody who understands it, and then somebody who can, figure out the differences between the mathematical system that Excel relies upon versus the JavaScript version of, and so the story goes that they realized they could just take this old library that literally hadn't been touched in maybe decades or so and compile it to WebAssembly, and then just call into it from JavaScript inside of Office 365 and get 100% compatibility with Excel all the way back to 1997 or whatever, without having to actually do any work re-implementing it. And I think, as you just said that, Fred, about this kind of Mozilla's vision of the world being the browser is your application runtime, the idea of being able to take old applications, or at least chunks of old applications, and run them in the browser, I can see why that would be a very powerful idea or very powerful step in realizing Mozilla's vision. But yeah, so they did this the right way, right? Mozilla not only, fleshed out a standard, originally ASM.js, and then that evolved into WebAssembly. They decided to use W3 as the standards body. Again, same one that does HTML and CSS and the standards we all use all the time. But they also reached out to the developer teams from, at the time it was IE, and the Chrome team and the Safari team, and said, hey, we should all work together doing this. We'll all work on the implementations. We'll all work on the specifications. And then instead of having Java that runs unevenly across all the browsers, or, Silverlight that runs in only one of the browser ecosystems, we'll have an environment that actually runs the same way on everything from, the refrigerator that for no apparent reason has a browser, all the way to your phone and up into your desktop and so on. Right. So that was kind of the original vision behind WebAssembly. So you get kind of like, they're like three characteristics that you really need for something like that, right? You need the security sandbox because you're running it in the browser. And again, like Fred said, if you're going to do a good job of this universal runtime for applications, you got to make sure that it doesn't become the universal vector for hackers to attack your system as well. Right. So you got that. As we all know, when it comes to the internet, we are impatient people. We want our pages to load very quickly. We want to get stuff done right away. We don't want to watch progress bars do anything at all. And so it had to be very fast. And it had to be cross-platform and cross-architecture, right? The objective, very similar to Java and .NET, was, kind of write once, run in any variety of ecosystems. And WebAssembly really kind of knocked it out of the park on that one. I mean, there are implementations that fit in 1 meg and can run in IoT devices, up to like the ones Fermyon uses, where we can run 300, 400,000 WebAssembly interpreters in a single process on a fairly hefty sized server. I mean, WebAssembly is just one of those very remarkable technologies. But the most audacious thing about the WebAssembly standard, and the biggest risk I think they took, was that they created a binary specification and said, and any language can run on this. As soon as all those languages go and add WebAssembly as a target in their compiler tool chain or as a runtime or whatever. And I mean, talk about taking a big gamble, right? C was supported out of the gate. It was really the only language originally, right? And you saw Rust come sometime later, and then something happened. And, it was sort of like the whole field of dreams, like if you build it, they will come kind of thing. People came and they built them, and there's a runtime for Swift and Rust and Ruby and Python, and they all have first class support now for WebAssembly that the core teams maintain. Really, as funny as it is, the laggard on WebAssembly is Java. Java is the last language moving of the kind of top 25 languages. Just about all the rest have at least some degree of support, from scripting languages like PHP to .NET and the whole .NET ecosystem to, the low level languages like Rust and Go and C. So it's been that, so that's kind of the backstory. And yes, you're right. Then, the story we just told was all very much about the browser.
Right.
Yeah, I was really skeptical when WebAssembly came in, because I don't know. I think I'm starting to be the old man that yell at the cloud. I've been known like that at Construct now, but the thing is, like, I've been through like the Java applet, like I've been through Flash. I was at Microsoft when like Microsoft basically kills silently, you name it
Silverlight.
before, Silverlight.
Silverlight,
Like
yeah.
they never announced that they killed it. Like it took like 2-3 years, but like they stopped supporting it and everything. So I went through all those like, technology that will save the world and that will make like developers' life
Yeah.
easier for like the browser. And I was like, okay, yet another technology. And especially when they say like, oh, you know what, like every languages will be able to run on it. I was like, bull.
Yeah. Sure.
Yeah, good. Like I've seen that, been there, done that. Good luck. And
Yeah.
I'm just to be honest now, I'm not a grumpy old man either. Like I'm still happy that like, my God, that works, and that's like a good standard. It's working well. So yeah, and we can have a show about it right now. So even better.
And then I can kind of connect the two dots for you, John, in your original question, which you asked a long time ago.
Yeah, I love that.
Because we're not a browser technology company at all. We're a server side technology company. We're a cloud technology company.
Right.
And like I said, we were coming out of Deus Labs at Microsoft. So I came into Microsoft from Deus, which is a small startup here in Boulder. That we actually got acquired by Engine Yard, and then Deus got acquired out of Engine Yard and into Microsoft. But we were doing very early Kubernetes stuff. We were doing PaaS. We were building a PaaS on top of Kubernetes. We built Helm and a variety of other sort of early CNCF projects. And so I was like entirely in the virtual machine container ecosystem and all about running services in the cloud, right? How do we run these things? How do we architect them? How do we manage them over the long term? Those were the questions. Browser was not my thing at that point in my career. I like wanted nothing to do with the browser, but we were trying to solve a particular kind of problem. And that was that we were looking at how serverless frameworks like Lambda, like Azure Functions, like Google Cloud Functions, how they were built, and figure out, how to overcome some of their critical weaknesses. So first of all, we wanted to be able to run them inside of Kubernetes clusters or inside of whatever your kind of runtime of choice was. Second of all of them have a pretty hefty cold start, like 200 to 500 milliseconds. And we were talking about how, we're impatient. Yep. We do not want to wait 200 milliseconds. In fact, Google's page ranking system starts to ding you if they don't get the first byte in 100 milliseconds. So we were looking at the, customers of Azure coming in and saying, we love this. Developers saying, this is an awesome way to write stuff. I write a function that, a request comes in, my function spins up, handles the request, returns a response, and shuts back down. And it scales really well, and my code weight is a lot lighter. So developers really loved it. And it was, a very elegant kind of way to be able to deploy and manage software where you didn't really have to think about the server processes and monitoring those kinds of things. Those were just part of the underlying foundation. And we were trying to figure out how to build a better version of that didn't have the 200 to 500 millisecond delays, that didn't lock you into one particular cloud vendor or require you to just use one language, like say Cloudflare and JavaScript. So we were trying to kind of solve this kind of, tangled up ball of problems. Yeah. And we were trying to do it first with virtual machines and containers, and just kind of ran into some headway, intractable problems really that we just never could figure out how to solve. So we were all together at an offsite. The whole team was together at an offsite, and we had spent the day, road mapping the future of Helm 3, working on Brigade, which is another project we committed to CNCF. We had just kind of rolled out of the first development cycle of a technology called CNAB, and we're going, okay, what are we going to do now? And we sort of dusted off the old list of serverless function problems. And we were sitting around after dinner, drinking maple flavored Canadian whiskey, which is every bit what it sounds.
It is Canadian here.
Yeah. Oh, we were in Victoria. We did our offsite in Victoria, which is just, it's the perfect area to do an offsite in the summer, because you could go and hang out in a conference room and then go outside in these evenings, and the evenings are so long and it's so beautiful there, and you can sit outside, and we had just come back from dinner and we're just sitting around at this table drinking maple flavored whiskey, which is maple and whiskey. And and we started talking about this list, and we're like, is there, we tried this with containers, we've tried that with containers, we've tried, unit kernels, we've tried speeding up the boot process, we've tried figuring out how to do this with C groups, and we can't figure out how to speed up the startup time to the speed you'd need if you were going to run this kind of serverless environment. And, somewhere along somebody says, well, maybe the problem is that our assumption is that whatever the compute layer is has to be either containers or virtual machines. What if there's some other compute layer that we could use? And that was sort of the trigger that led us down the path to saying, is there another runtime kind of thing that could do this? What do we need? Well, we need a secure environment. We need really high performance. We need multi-language support. Basically the list of features I rattled off about WebAssembly were just exactly the features we were looking for. We just wanted to pop them out of a web browser and drop them in on the server side.
Right.
And that's effectively what we started doing. This is 2018. We started researching that.
Fascinating.
That is actually fascinating. You said a couple of things. One that I want to come back after we're kind of like circle, and we've talked about SpinKube and like WebAssembly. You talk about Helm, so just want to be sure we're gonna talk about this. We're part of the process. Like I want us to talk about the journey and like the story behind it. But I personally would like to learn a little more about like the Spin and SpinKube. Specifically, we talked a lot about WebAssembly, and that was perfect, especially for folks that do not have that background. But now in terms of like, okay, how can I use like all the amazing things you talked about?
Yeah. Maybe it's a good time to whip out a terminal and try a little bit of a demo then here.
It's always a good time to open the terminal.
Ads are always in the best mood.
All right. Let's see. We'll share the screen here, and we will.
Fun quick story while Matt's pulling up a demo. When I met Matt not too long ago, we were talking through the format for the show, and I only knew him as the CEO of Fermyon. And to try and find common ground between Matt and his space and me and our sort of construct Kubefirst space, I ignorantly asked my buddy here, can you install this thing with a Helm chart or something? Like, I'm just trying to find that common ground. I had no idea that I'm talking to the guy that like literally invented Helm. and so politely, without skipping a beat, he just kind of said, yeah, sure does. It's got a Helm chart. It was probably a full 20 minutes before I figured out that the history of you and Helm. And that was a fun one to play back in my a little later.
And I mean, it's the funny thing for me is that, Helm represents for me like a very specific technology I was pursuing in a very particular time in life when I was trying to figure it out and all of that. Never at any point did I think I would be using Helm to do something like installing WebAssembly stuff into Kubernetes clusters. It was just not a thing that ever seemed like. It is one of those things where you think like, yeah, I'm doing this thing over here and I'm doing this thing over here. They're never going to cross paths. And then, of course they do. And then it puts me in a very weird like mental state where I'm like, I am sort of relearning the thing I built in a different context. And that's kind of breaking my brain a little bit. Right.
Yeah.
So, okay. I assume you can see my screen. Okay. There
we can.
TypeScript
is another thing. Just to a little story too. I was working at Microsoft when we announced internally TypeScript, and the entire developer advocate teams we were all like old men and women yelling in the cloud. They were like, what are you talking about? Like, let's go. Microsoft trying to reinvent again something that does exist, and like, who do we think we are? and like nobody, like everybody like saw potential, but everybody was like, okay, Microsoft, you're still doing something. That is why most people don't like you, because it was during the Ballmer era. Nobody liked Microsoft at that time, and when we started to realize the benefits of TypeScript and it really became a thing and became popular, I was like, okay, good call. We were all stupid when we thought about it, but it was just like, oh no, you're doing it again, Microsoft.
This is wild because I feel like I'm basically telling a story that runs in parallel to Fred's, recent career journeys, which is awesome. And this is going to get funnier in just a moment. So, but I'm actually a huge TypeScript fan. So I just happened to be in a directory named TypeScript because I was thinking maybe I'd create a TypeScript one. So we could, let me see if I can spell while talking. So Spin basically helps you scaffold out your program initially. And one of the things it does for you is, so you've got a whole bunch of different compilers that can all build to WebAssembly, right? The compilers will depend on the language. So you can kind of see here, there's a version that'll write an HTTP, that'll template out an HTTP handler in C, in Go, in Grain, which is a WebAssembly only language, and JavaScript, PHP, Prolog, which I admit I don't even know how to code, all the way through. We're going to do TS for TypeScript. So this is, I downloaded and installed Spin, and basically, that's about the extent of configuration. I happen to have the JavaScript toolchain installed here with NPM, and we'll use that in a minute. But if I want to create a new serverless function, I just basically say, okay, from the template HTTP TypeScript, I'm going to do a spin new, and then let's give it a name. Did I spell that? No, I did not spell that. It's always good when you get off to a good start and spell the. So we'll do a hello Kubefirst, and it's going to ask me for a direction. I mean, a description. I'm going to do a hello app. It's going to ask for a path. I'm going to leave it at the default there. We'll see what that does in just a moment. And then here's our project. So I'm going to switch over to VS Code here so that it's a little easier for us to navigate as we go through. And of course, it opened it on a different screen. So we'll be dragging that over here. So here's our brand new program that we just scaffolded out with Spin. I'm going to open a terminal here so that we can keep typing our Spin commands down here. But it scaffolded out a kind of basic directory structure for me, right? So here's my source. There's some TypeScript files. It's got kind of the usual suspects here, package.json file. The spin.toml file is really the one piece here that's Spin specific. And it says, when it's basically instructions for how to compose the WebAssembly file from the whatever target language I have and so on here. So take a quick look at it, but you can basically, the important part for now is we see the command that's used to build it. We see that it's going to produce a WebAssembly as an output. And we can see here that it describes sort of how the HTTP trigger will work, that when we hit / and anything under / on the HTTP server we're going to start later, then it should execute the serverless function named hello Kubefirst. And we can, take one of these TOML files and embed, hundreds or thousands of components of WebAssembly components if we wanted to, but we're of course just going to do one. So, like any good NPM program, we do want to initialize it with an NPM install. And while we're doing that, so it's just pulling down the kind of base packages. We can go ahead and take a look at what our application looks like. And this is it. This is kind of what the core of a serverless function looks like. You have a function that takes a request, builds a response, and exits. That's all it does. So there's no...
Oh, sorry.
Yep.
I thought I caught like a time to insert something, but like if you want to continue the funny part about my career, I work at NPM too. So.
Are you serious? Okay.
Serious.
Okay. This is going well. This is going
developer
well so
advocate there.
You would think that we had planned this way, but this would require like 5 years worth of planning.
When I saw you NPM install, I was like, I need to say something now. I mean, like, even if it's not relevant to the show, I need to say something.
That is so awesome. So yeah, while we did the npm install, and everybody should thank Fred in the comments for yet another contribution to this ecosystem that I'm taking advantage of. So we installed the Fermyon SDK package. That's what defines the request and the response builder. Most of this stuff is really just kind of straight up boilerplate JavaScript or TypeScript, right? Nothing particularly special about any of this. So there we've got a hello, hello universe seems a little bit ambitious.
I like your way of thinking.
We'll narrow the scope of this demo. So right, we just changed one little line in there, and now we can build it. And so we'll spin build. We'll take this JavaScript TypeScript application, do all the TypeScript to JavaScript conversion, do all of that kind of stuff, but it's building a WebAssembly file. And I know I'm supposed to be doing the quick demo, but I want to tell you how this works because this is really cool. And also because Fred's going to go, well, actually, when I was, so if I were doing this with Rust, right? Rust is a compiled language. Because of that, when you hit the compiler tool chain is going to say, all right, as input, I'm reading the source code. I'm converting it into a low-level instruction set. Instead of being, ELF or something like that, the binary formats for various operating systems, the output's going to be WASM, WebAssembly. JavaScript is a little different because JavaScript is, as the name implies, a scripting language, right? So, and it's inherent in the way JavaScript and TypeScript work that they have to be executing within a scripting runtime because of the dynamicness of the language. So when we're building a WebAssembly runtime, what are we, or a WebAssembly binary, what are we doing? Well, effectively, we're packaging our script files with the script interpreter. And then we are basically initializing all of that. So we load all of the files into memory and then freezing that as the WebAssembly binary. So you basically have like an initialized runtime, which means you can actually run very, very quickly. But it's really cool. Underneath the hood, this is actually bringing in SpiderMonkey. So SpiderMonkey is the JavaScript runtime that's inside of Mozilla Firefox. That's the runtime that's actually running inside of this particular application. It's SpiderMonkey with a whole bunch of system interface calls that make it behave more like a serverless environment than it would a browser environment, but it's that same runtime. So you get all of the JITting and all of the kind of special runtime performance enhancements that you would normally get in a JavaScript runtime. But it's just wild. So there we know we've built a hello world application, and inside of this, I think it's in targets here. Yeah, there we go. So let's throw some flags on that so we can see LAH. Okay, so this is a fairly large binary right now for a hello world, simply because we have all of SpiderMonkey in here, and it doesn't actually grow sort of proportionally. It's like you got an initial fairly large base size, and then it grows very little. If we were to build a hello world with Rust, this would be like 200K or something like that. So you really, depending on how you're building your WebAssembly environment, the sizes will go up or down. And there are optimizations we can do and all kinds of stuff. But the bottom line is what we'll see is that it doesn't really matter. It's so fast at this point.
For languages that need a runtime like a .NET Core or something like that, that like needs that framework environment in order to run, are you getting in the WebAssembly, excuse me, in the WebAssembly runtime, are you getting like the full version of that framework and all of the functions are available to the function that you wrote that's making calls to that .NET framework? Or is it like a scaled down version of only the portions of the framework that were used for efficiencies? Like, how does that work for languages that need a runtime typically?
I mean, it's a very straightforward question with a surprisingly complex answer. Essentially, there are a couple of limitations to WebAssembly that you don't get for some languages. We're using TypeScript, and we're using SpiderMonkey, and TypeScript's asynchronous model is single-threaded. But for languages that have multi-threading, WebAssembly doesn't currently allow true multi-threading. So, if you're using Python and you call a threading function, you'll get a runtime error. because the function won't have an implementation.
Got it.
Some of the standard library, and there are it's kind of one of those things where the vast majority of the standard library works, and then there are some really strange edge cases where you're like, oh, no threading, huh? Okay, well that means that these particular libraries won't work. Huge amounts of the Rust and JavaScript ecosystem work really well because they were built in a way that kind of thing doesn't make a huge difference. But Python is one where we've discovered, sometimes you get surprising incompatibilities there. Threading will come along in WebAssembly sooner or later. It's just a work in progress because it's very complicated to implement that in a language neutral way.
Yeah.
But for the time being, some of those features don't work. Then the second half of that question is really sort of like, when you build the binary, what are you losing as you build the binary, right? So it's not just a matter of what features are missing from the underlying standard libraries. We don't do any of the fancy tree shaking stuff yet, but you should be able to, and that'd be one way to cut this runtime down, right? You should be able to say, well, actually, huge portions of this of the underlying runtime are never executed by my application. Right. Can we just kind of remove those out when we build the binary? We don't do it for the JavaScript runtime. .NET I'm not positive about. .NET 9 has beta support for compiling directly to WebAssembly, and it's been a blast. It's so much fun to work with. But I think they too are kind of like that. As a first pass, we'll leave it all in, and then later we'll figure out how to optimize. Right. Some of the statically compiled languages, it's just the way compiling works, right? So with Go and Rust, you're not going to be importing the libraries in the first place, so they won't end up in the runtime, or not all of them will end up in the runtime. So sort of complicated answer, but the TLDR is, if you're not threading, if you're not doing a lot of threading, and not doing a lot of long-running socket servers, which of course are sort of incompatible with the serverless way of doing things, likely you're going to be able to use most of your usual tools.
Right on. Appreciate it.
So while I was talking, we did the spin build. We saw the WebAssembly file. I typed spin up, which just starts up a local instance of a spin runtime, hangs it off of port 3000 on my local host, and then I can go try, making requests against it. So this kind of, this kind of idea is in your local development loop, right? While I'm working on my code, I should be able to use one tool and basically control all the things, right? The creating something new, building it, running it, eventually doing a spin deploy to deploy it somewhere. And then when it comes to the remote runtime, I really don't care, right? I'm not shipping a daemon process to it. I'm shipping a WebAssembly binary, and it's managing the long running processes and port allocation and routing and all of that kind of stuff. So it's different in kind from the way we build microservices, where every microservice typically has an HTTP daemon that you start up, and then you're kind of hanging your routing table off of that. In this case, it's really the case that literally the WebAssembly function is getting executed at when the request comes in, is executing to completion, and is then getting shut down. It just happens that when we're doing this kind of locally, we're running spin as our sort of long running host to listen for the requests and then delegate out and run that WebAssembly, if that makes any sense. Yeah, makes sense. If that doesn't make any sense, I apologize.
Yeah, it makes a lot of sense.
So, we're just going to do yield curl command. And what did I spelled localhost wrong. And there's our, little hello Kubefirst kind of thing.
That's neat.
So that's a basic idea. I'm going to pull over another app that I opened just to kind of show you where it can go from here, right? And I'm not going to spend much time on it, but I thought it'd be fun to kind of see one where, so this is a little internal project I've been working on called Luxor that is a complete content platform. So it has a CMS, it has a QR code generator, it has an authentication system that can be shared. I think it's got something like 12 or so components. And here, if we look at that same spin toml file that was just one endpoint declared, this one has a whole bunch of endpoints declared. And, this, if it goes to static / ... it's getting handled by a file server. It goes to navigation, it's getting, and each of those is basically mapping a path to a serverless function that's a WebAssembly binary. And so then when you start scrolling down here, you can see this application is a whole bunch of moving parts, each of which has its own spin components. And if we were to look through the languages here, we'd see some of these are in TypeScript. Some of these are in, I think this one's in Rust, and we're just kind of mixing and matching. And that's kind of another interesting thing that you get when you're in this WebAssembly ecosystem. everything's compiling to the same binary format. And it's even possible for the binaries to interact, the libraries to interact with each other. They're called components in WebAssembly. And so because of that, it's possible to call from my TypeScript program into my Rust program as a library, or from my Python program into a C program, and from the C program into a TypeScript program, and from the TypeScript. I mean, it's really pretty remarkable that because you have this sort of standard runtime, it no longer matters what the language is that you're writing the source code in, because the runtime knows how to wire things up together. So in this case, we've got sort of this amalgamation of lots of different languages that are doing things together. That, by the way, so the name of that whole technology is called the WebAssembly component model. And it is a fascinating piece of engineering, because it kind of takes ideas you might have heard of before from something like gRPC, where you define what an interface looks like, and then, you know, in gRPC's case, you're calling across a network. In WebAssembly's case, you're literally calling, the runtime's calling on your behalf, binary to binary inside of the WebAssembly runtime. But it's just a remarkable technology and a lot of fun to dig into if you want. The Fermyon blog, which is fermyon.com/blog, you can kind of skim back through articles there and see lots and lots of different things there about how that works. The Bytecode Alliance, which I think is bytecodealliance.org, that's the standards body, or that's the group that is writing the specification that then gets ratified by the W3. So you can even get in and read the specifications, because it's a sort of industry standard kind of thing. So that gives us kind of an idea of how to build these applications. You know, from here, it would be possible for me to, you know, deploy this into a Kubernetes cluster if I had the foresight to set up a Kubernetes cluster beforehand, or, you know, deploy into Fermyon Cloud. And basically, the developer experience is just such that you're doing this local development, and then when you're ready, you can either package as a Helm chart and ship it, or dump it out as Kubernetes manifests, or leave it. Actually, the kind of preferred way we've been doing it is there's a spin command that will package everything up into an OCI image, Docker Hub image, right? And then just deploy that. But it doesn't actually have a container runtime inside of it. It's just packing the WebAssembly binary and the supporting files into that same manifest format, but as WebAssemblies instead of as layers on a layer diagram. So, I mean, it's a rabbit hole that you can go pretty deeply into if you want to. It's a lot of fun. Because essentially, I think our design philosophy at Fermyon has been, you know, this is the cool new technology, right? Being able to write serverless functions this way. And as you noticed, I mean, they're just amazingly fast to run. And when we're running in server mode on a big server, we're talking being able to sustain 700,000 concurrent invocations of the WebAssembly sandbox. That's huge, right? And do that, you know, 700,000 requests per second is 700,000 separate WebAssembly sandboxes standing up, handling a request, and then shutting down. It's pretty impressive compared to the 200 to 500 millisecond cold startup time you get with sort of the serverless Gen 1. So there was that, and that's the cool thing, right? And that's what we wanted to focus on. But when it came to how to deploy it and how to work with other technologies, we really tried to do it in a way where we were saying, okay, we could invent a new packaging format, or we could use the OCI format that everybody in the container ecosystem already uses. We could write a new orchestrator, or we could build SpinKube and basically make it runnable inside of Kubernetes. You know, we could, and you know, basically just kind of sticking with this idea that instead of, you know, suffering from the ever-present tendency to say, well, it wasn't invented here, so can't use it, to kind of switch that and say, look, these things are widely deployed, really well understood, tremendously well documented, commercially supported. Let's use all of those things. And let's just say, we're going to spend all our novelty points building this really cool, you know, serverless platform. And so that's kind of how we've done it. Again, if you want to dig into all that, it's all at developer.com.
Sorry, I thought it was worth some applause time, because I'm a big fan of trying to reinvent the wheel. So
it's the hardest thing as an engineer to not say, well, I can probably do it better, and then spend 3 years proving yourself wrong, right?
I know. And so for someone who would like to use Spin on a Kubernetes cluster, like SpinKube is the way to go.
Yep. You can install that with a Helm chart. It's in the Kubefirst catalog. There's so many ways that you can get going with that one.
It is. You stole what I wanted to say next. Is basically that.
Sorry, everybody, pretend you didn't hear that. Go ahead. You can say it now.
That's totally fine. But I was going to say, like, if you are creating a cluster with Kubefirst, by now there's the GitOps catalog that helps you to install, application on your cluster, but like in a GitOps way. So everything is added to your GitOps repository. So for me, it's the only way to do ClickOps correctly. It's by using the GitOps catalog, and the spin operator is in the catalog for you to enjoy easily on your Kubernetes, on your Kubefirst or Kubernetes cluster created with Kubefirst. So.
And Matt, just to just kind of ask one more sort of generic question for my own mental scaffolding, like, almost every shop that I work with is a SaaS shop of some sort. They're building microservices. They're building stuff to go from a dev to a stage to a prod environment, so that some prod thing can make some money for some company. And I feel like we mapped out most of the compute space. We've got the clouds covered. We've got the Git ecosystem squared away. We've got secrets. We've got users. We've got all the stuff. And I'm trying to find the spot in my brain where I'm supposed to be thinking WebAssembly. And I can see some advantages. I can see, certainly from a scale, from an interop standpoint, from a polyglot standpoint, there's a lot to like. I just don't yet understand when I should be like closing my eyes and thinking, WebAssembly might be a good opportunity in this exact moment. Like, is it whenever I'm thinking it'd be nice if that was a Lambda? Is it when I'm thinking it'd be nice if this web app could call some old C library and we don't want to rebuild that library in a different language? Like, help me understand when I should be thinking WebAssembly.
Yeah, I think there are kind of three big cases. One that you already hit was, if you're liking the way you're building Lambda stuff, but you don't want to be in Lambda, or you're liking the format of building a Cloudflare function, but you want to run it in your Kubernetes cluster and not on Cloudflare's edge, or similar with Azure and every other cloud vendor out there. If the idea is, I like that pattern, I want to run it in my Kubernetes cluster, this is the way to do that, right? So that's case number one. Case number two, I talked about the scalability of it, and that actually ends up being very important. So case number two is sort of the density/cost story, right? And that is when we normally create containerized apps, we're starting up a runtime that runs all the time. So that causes sort of problems on both ends of the performance spectrum, right? If you create a tiny app that gets maybe a dozen requests a week, and you install that, you're still spinning up that container. That container is running 100% of the time, claiming its chunk of the CPU and its chunk of memory, even if it's idle 99.9% of the time. And recent research suggests that actually, I think this was Datadog who did some research on this and said, actually, most applications, 78% of applications are idle. Sorry, it's the other way around. Most applications are idle 78% of the time that they're available. And Kubernetes kind of makes this worse because you're spinning up not one instance of it, you're spinning up 3 instances of it with every deployment, or 5 instances, or however many your replica set is set for. So in those cases, on sort of the low end, it would be nice if you could say, actually, I don't want to claim those resources, right? When a request comes in, use the resources and then free them back up again. So on that end of the performance spectrum, WebAssembly is really good. So if you're trying to take care of those, sort of energy sucking, resource sucking vampires that need to be there, but only to be accessed a little bit. Yeah. That's the category. And on the opposite side of that performance one are the ones that can get huge incoming bursts of traffic, right? So we work a lot with, so for KubeCon in Paris, Zeiss Optics, a technology, a company that does optical technologies for stuff, amazing, like everything from, Elton John's sunglasses to the optical setups that are used in space mirrors and fabricating chips and stuff like that. They would get huge bursts of orders that would come in. I think they said like 50,000 would come in, and they would need to churn through all 50,000 as fast as they possibly could. And then once the 50,000 were gone, they were done, and they needed to free up those resources and use them to handle some other piece of their internal. And they were sort of jockeying around Kubernetes resources to try and keep their cluster size small. They came in and tried out Spin and went, oh, wait. So in this case, we don't have to do any of that jockeying, because Spin literally can scale up to hundreds of thousands and back down even on pretty modest size, large, extra large size virtual machines in AWS or in Azure. And so on both the low and high performance side, it can really help out. So that's case 2. Case 3 is sort of the opposite side of the network diagram. If you have a lower resource environment, like Edge, CDN Edge, or IoT devices,
yep.
And you want to still be able to run sort of a Kubernetes environment there, but you cannot run containers because they have too big of a runtime, or they are too expensive to operate in that environment. This is a good alternative there. So we work a lot on Edge. In fact, at KubeCon, spoiler, we're going to show some IoT demos where we're doing sort of aggregating data across IoT endpoints and building a little application out of it. We'll be demoing that at our booth, at SUSE's booth, at Ampere's booth, at a whole bunch of different booths there. So there you go, a little bit of a KubeCon spoiler.
Very cool.
Kind of right? So it's sort of like, if you're already bought into serverless, or you're really trying to cut the cost or improve the performance of your cluster, or you also want to run Kubernetes in sort of a different sort of environment, those are 3 cases where you'd say, ask Matt if WebAssembly is right for me, right. That kind of thing. Right. And I will say, yes, it is. Side effects may include learn TypeScript, 8 hours in the Rust documentation. But yeah.
That's fantastic.
I love that. Speaking about KubeCon, by the way, we won't have a booth, but some of us at Construct's going to be there. So John's going to be there. I'm going to be there. Jared, our CTO, is going to be there, and Bill's going to be there. So please hit us up. If you want to talk about, Kubernetes, cloud native, you want to learn more about Kubefirst Pro, Colony, or new product, or, you just want to make new friends. It doesn't look like that, but we're friendly people. So hit us if you see us at a talk or during the break time. That's going to be a fun week. That's going to be an interesting week, because as far as I know, John, I don't know for you, but it's going to be the first time I go to KubeCon where I don't have a booth. So that's going to be like me as an attendee. I have some business goals though with that, but still, I'm going to be there like as an attendee. So it's going to be a special conference for me.
Yeah, no, likewise. I've also never been without the I won't call it a burden. I'll call it an advantage of having a booth. But I am also looking forward to having some unshackled time on the floor, talking to companies like Fermyon and going to some good talks, and really just getting a nice, good, deep measurement of the pulse of the cloud native community.
And I know it may sound like it's the end of the live stream, but I really want to talk about Helm. So that is not the end. Like it's not every day we have the chance to have someone like you on the show. We're part of let's say cloud native history. I mean, like everybody's using Helm. So whatever you want to share with us, I don't have a specific question more than like, understanding maybe a little bit the journey, how it started. And this is what I had in mind. I just wanted to, use that opportunity.
I mean, I guess if there's any one thread that weaves through all of these things, it's like company offsites. So, we're talking about the Vancouver Island offsite and coming up with the WebAssembly idea. We were doing an offsite in Boulder, Colorado for DAIS. And on the same day, both the Illustrated Children's Guide for Kubernetes and Helm were born. And this is sort of the short version of the story. So we were doing the offsite, And we had just decided, but prior to this, we were experimenting with lots of different orchestrators, including Mesos and Swarm, and the orchestrator wars were the big thing then. And we had just decided that Kubernetes, which was still at 1.1, was going to be the one that we landed on, and we chose to build our next version of our PaaS platform on. And so we had this offsite that was designed to sort of let everybody in on what that meant for us, what the new roadmap was going to look like, and then get people kind of energized. And so there were some sessions on like introducing Kubernetes, and then there was like a hackathon thing at the end. So the CTO says to me, well, you're one of the, you're the reason we're doing this Kubernetes thing, because you and your team were the ones who really liked it. So I want you to give a presentation to the company about Kubernetes and just kind of introduce it. And I said, okay. So you mean like, both both sides of the engineering team? He's like, no, like the whole company. Like, I think finance is going to be there and marketing. And I'm like, you want me to explain Kubernetes to finance and marketing? All right, I'll give it a shot. And he says, don't worry about it. I gave you the slot right after lunch. And I'm like, wait, so they're going to come in and like fall asleep while I'm telling them about Kubernetes? So I went home and posed my kids' stuffed animals around the house, a giraffe and an owl, which was actually originally like a little ring box for a toy kids ring. The Fippy gopher, the Go Gopher that I had gotten at the Gopher Con in Denver. Posed them, took some pictures, put together this really hokey slide deck that I called the Illustrated Children's Guide to Kubernetes, even though it wasn't illustrated at all. So I got in there after lunch and kind of did the little walkthrough. And Karen Chu, who was in the marketing department there, comes up to me afterward and is like, we really could make this into an illustrated guide. And I'm like, and she's like, no, give me a shot. And went away and did the whole rest of the thing. And it was awesome. But later that afternoon, we had a hackathon. And the objective was introduce Kubernetes, then have a hackathon where we can all kind of try something out, right? And so my team in the hackathon, we were among the more seasoned people in the group when it came to Kubernetes. And we went, let's try something kind of fun. Let's make like NPM for Kubernetes. And so the very first version of this, we called it Kate's Place, KS, but it was all like coffee shop themed. And we were trying to like evoke the idea of like a warm, friendly coffee shop. And the original name for Helm charts was Shots. So you'd download your shot and then you'd install it and stuff like that. At stake was a $75 gift card, because the winner of the hackathon got a $75 Amazon gift card. We won the gift card and we split it 3 ways. Each of us got $25. I actually spent mine on coffee. And I thought that was the end of it, right? We made this Kate's Place thing. Day after, we all go back home and I'm sitting in my office and the phone rings. It was actually a phone, like really a phone rang. And I picked it up and it's like, hey, this is Gabe, the CTO, and Bo, the CEO. Do you have a second to talk? And I'm like, oh no, I did something really wrong. My boss's boss is calling me and the CEO is on the phone. I'm getting fired for something. And they're like, so about the offsite. And I'm like,
here we go.
I don't know where this is going. I don't know where this is going. And they're like, that demo you did was really cool. And we think we could make it into a real thing. And I'm like, really? Okay. And they're like, there's just one condition. And I said, okay. And they said, you cannot call it Kate's Place. That's a horrible name. We don't like the coffee metaphor at all. So Jack and Remus and I, who had started it, we started hunting for names, and Jack and I literally pulled up a nautical dictionary and were reading words back and forth to each other until we landed on Helm. Then once we had Helm, we had like charts as in nautical charts. And we actually had a whole sophisticated nomenclature that we never got around to building. We had chart cases and all kinds of crazy stuff. But Helm and charts, kind of stuck. That became my full-time job there from that day forward, and then continued on into Microsoft when we did Deus Labs. And now I approve the occasional PR and weigh in on why we still don't have great CRD support. And that's kind of my job. But at KubeCon, we are going to kick off the Helm 4 process. So, if you're out there thinking, I've always wished Helm could do this, or I've got an idea for how Helm could do that better, show up to the sessions at KubeCon in Salt Lake City, drop into the Helm Slack channel and CNCF and drop some ideas there. I know they're going to be sort of unveiling everything in the next few weeks. And then there will be a process to kind of figure out what features we're going to do. And then that year-long development process kicks off. So, it's a good time to ask because the story is fun. And then the ending of it is, and there's more work to be done. And we're going to get that next round kind of kicked off now.
Yeah, no, you could do worse than that. Set up and swing. And that's that is a super fun story. I also didn't fully recognize your involvement in Fippy and Friends, which is just I'm kind of a family guy in the Kubernetes world. My baby girl asked me what I do, and it's just like, oh, baby. But the Fippy and Friends book does a good job, not just with baby girls, but also with your parents. It works great. Apparently with the accounting department. And no, I truly, every single time somebody comes into my space and doesn't know Kubernetes, that's my go-to 100% of the time. And everybody agrees that it just sort of lowers the barrier of intellectual gating. It lowers the barrier of understanding just a ton, and allows you to kind of look at this stuff in a very simple way, in a very non-imposing sort of format. So I really appreciate the effort that you put forward there.
Well, if you don't have one of these, the latest one we'll be giving out at KubeCon, Fippy's Field Guide to WASM, which is the latest installment that, as you might guess, is sort of camping themed. That Karen Chu and I wrote together. So we'll have some of those at the KubeCon booth.
Matt, if I show up at the KubeCon booth, do I get an autographed version of one of those from you?
I don't know. I'll see if this one is. Yeah, definitely. Somebody will sign it for you, and it might be me and Karen.
All right, it's a deal. It's a deal. Let's do it.
Yeah. So we'll have some fun giveaways there. But yeah, that was kind of we've had a good time doing those over the years. My favorite was the zoo one. Karen's favorite was, I think, the spy one. Actually, we both are supposed to say it's the WebAssembly one because that's the new one. But the zoo one was kind of fun to do with the CRDs page on the last page of the book has always been my favorite. So, and all of those are at Fippy and Friends at the CNCF site. So you can go to CNCF probably /Fippy or something like that, or maybe it's Fippy.io. I don't know.
It's not
and they've got all the books there free for download. So you don't have to wait to KubeCon where you can physically grab a copy before you can read them.
Right on. Very cool. Very cool.
That's amazing. That's everything I wanted to know. The story on Helm. So that's amazing.
I like telling that story because then people forget to ask about CRDs. And
now that you're talking about CRDs.
Look at the time. I have to wash my hair.
Yeah, I have to wash my hair too. So I understand. So, gentlemen, I guess I bring us to the real hand of the show. Anything else you would like to share with folks, Matt?
I mean, the fun stuff is that, I think this is a next wave of kind of cloud computing and a really fun way of trying out a new technology. And as you saw, one of the things I didn't point out but should have said explicitly is you can start this and play around with this technology without having to be a WebAssembly expert first. It was the same with Docker and containers. You didn't really have to know how containers worked before you could build them and start playing around with them. It's the most powerful way to learn a technology, is to be able to get your hands dirty, building your first thing, and then kind of work your way back into understanding the technology. So I always worry that people are going, I have to learn another new technology and learn a bytecode format and download a bunch of tools. It's, we did our very best to make it easy to do. So, reach out to us in our Discord, which is linked at the bottom of the Fermyon.com and developer pages. If you got any questions, because we'd love to help. It sounds new, we told a really wild story about a thing that runs in the browser and was plucked out of the browser and now runs in the servers. We didn't even talk about, some of the other places it's run, but it's really not a technology that you have to master before you can take advantage of it.
That's great to know. Yeah. And for anyone that's a Kubefirst user, Fred got that into the GitOps catalog this week. So if you want to take it for a spin, SpinKube is right there in the GitOps catalog. Just drop it in your management cluster. Reference this video on the Hello World and give it a whirl. And my buddy Matt will help dig you out if you need any help, I'm sure. If you need any help from our team, obviously you can go to the Kubefirst community, and we'll try our very best. And we know how to find Matt if we don't know what the answer is. So.
They've got an air tag taped to my back.
That's right. That's right. No, I appreciate you coming on the show and helping me understand WebAssembly and where it fits in the industry and where it fits in the sort of development architecture mindset. And I thought it was a really good explanation and a really good demo of how approachable it all is. And bonus, how it runs in Kubernetes, which is how I think everything should run. So,
and let the record reflect that Fred was there every step of the way.
Every step of the way, just like
thanks for talking about my career. That was a nice addition to the show. I like that.
Yeah, thanks for having me.
Fred, send us home, buddy. You got anything to tell us?
Yeah, may not be the best one, but you know, I have
a
question for you folks.
Disappointed.
What I cannot do those seriously anymore. What did the computer do at lunchtime?
What did the computer do at lunchtime? It compressed some bytes.
You were close. What did the computer do at lunchtime? Had a bite.
It had a bite. That's a good one, Fred. That's a nice.
I'm gonna be telling that one to my kids.
There we go. There we go. Get in the next Fippy book.
Yeah, that's right.
Awesome, folks. So that's the end of the show. Thanks, Matt, again for being a guest. Thanks, John. Always great question, great comments. Always a pleasure to do those show. Thanks, everybody who watched live. Hopefully it was as interesting for you that it was for us. I'm sure it was. And thanks also for people watching the recording. So as John said, if you have any question, please let us know. And we're going to see each other in 2 weeks for the next Kubefirst Live. Bye, everyone.
See you, everyone.